Okay, pod one, give us a strategy you use. Guess and check. Pod two.
You take it down step by step.
Pod three. Yeah. Okay, common sense. Anything else? Anything else? Okay. Pod four.
Already has guess and check.
Guess and check. Anything else you talked about? Okay. Pod five.
Look at your variables. Like the different things you're given.
Okay. Pod six. Find a pattern. That's a good one. Process of elimination. What about work backwards? Is that sometimes a strategy? No.
Yeah.
Yes. Okay. What we're going to do, I'm going to put it as the next 5 days. I would love to say week, but it may bleed into next week with our snowstorm. We're going to be working with trigonometric identities. And I'm going to just tell you up front, it's going to feel a little bit like solving a puzzle. Okay? What we're going to do is I'm going to teach you these identities today. I'm going to teach you how we can work with them. And starting tomorrow, we're going to verify identities. Okay? So I'm telling you where to start and where to end, and you kind of have to do the work in the middle. All right? So today might not feel as puzzle-ish as maybe tomorrow will, or the next time I see you. But if you like solving puzzles, more than likely you're going to enjoy this part of the chapter. Okay? So we have some identities. What is an identity? And what do you think of when I say that word? Absolutely. Okay. What is your identity? Like when you say like my identity, like what does that mean? Okay, well yes, it's all of that very important stuff, okay? It's you though, right? It's everything that holds true for you, right? So trigonometric identities are things that hold true with trig functions, okay? So you actually kind of know some of these already, but we're gonna like officially write them down, okay? So the first identities that we're gonna talk about are the reciprocal identities. You actually already know these, okay? Reciprocal, when I say reciprocal in our trig chapter, what do you think of?
Cotangent.
Cotangent. And what do we know about cotangent?
It's reciprocal.
Is 1 over tangent. What else?
Secant.
Secant. And secant is 1 over cosine. And we have, which is 1 over sine. Okay, so you've known these, but now I'm telling you what they are. They're the reciprocal identities. Okay, and because these hold true, we can also say that the sine of theta is 1 over cosecant. The cosine of theta is 1 over the secant of theta. And the tangent of theta is 1 over cotangent. You know the first three, you know the second three. as long as the angle is the same, okay, these identities are true. So if this angle was star, this angle is star. If this angle is 5x, this angle is 5x. You need to remember these because you are going to have to use them over and over and over. But you kind of already know them, so these shouldn't be too bad. Let's talk about the quotient identities. You kind of already know these already. Okay, I want you to think of the unit circle. When do we use a quotient to find something? What do you say? Tangent. And what quotient do we use for tangent? Okay. For our unit circle, we use y over x. Well, we know y represented the sine, and x represented the cosine. So the tangent is really sine over cosine. Which means, in turn, what's the cotangent? Cosine over sine. Okay. The Pythagorean identities. Okay, so you need to know the quotient identities, but you kind of already do, so those aren't going to be too hard to remember. Okay? The Pythagorean identities are going to be the biggest. Okay? I would like you to think of the unit circle very quickly. A coordinate. X, Y. Right? If I draw a triangle here, what's the hypotenuse? In the unit circle. Okay. And what's this distance right here in our triangle? X. And this distance is Y. Okay. You don't need to write this down right now. We're just going to kind of think about this. Pythagorean theorem. X squared plus y squared equals 1. You agree?
Yeah.
Okay. The x in the unit circle, what does it represent? The cosine of our angle. The y in our unit circle, what does it represent? The sine of our angle. So our Pythagorean identity, cosine squared plus sine squared equals 1. Sine squared plus cosine squared equals 1. Okay? I will probably write it more often as sine squared plus cosine squared. So I'm going to go ahead and do that now. It's the commutative property, so it doesn't matter which one comes first. But I'll just tell you, I'm going to write it like this more often than not. That's just what I'm used to. So if you need to write it like that in your notes, that's how I'm going to write it. Okay? Now, that's the identity. What we can do with it is we can use it more than just sine squared plus cosine squared equals 1. We also know that you don't need to write this down, but think about this. Sine squared equals 1 minus cosine squared. Okay, we can use it that way. We can rearrange it as we need to. Okay? Now, there are two other Pythagorean identities, and we can get them with just some simple reciprocal and quotient identities. Okay? So what I want you to imagine, don't write this down yet, just think this through with me. What I write in green, don't write. If we divide both sides by sine squared theta, what is sine squared divided by sine squared? 1. What is cosine squared over sine squared? Careful. Cotangent squared. And what is 1 over sine squared? Cosecant. So here is your second Pythagorean identity. 1 plus cotangent squared equals cosecant squared. And same kind of thing, we can rearrange that as we need it. Okay, if we want cosecant squared minus 1 equals cotangent squared, we can write it like that. Okay. All right, we're going to get the other one, because there's a third Pythagorean identity. We're going to divide both sides by cosine squared theta. Okay, what do we get? What is sine squared divided by cosine squared? Tangent squared. What about cosine squared divided by cosine squared? 1 equals 1 divided by cosine squared. Secant squared. There's your third Pythagorean identity. Okay? You can either memorize all three, or you can remember this first one and then figure out the second two. Okay? I will tell you right now that on your quiz, which is scheduled for Friday, we'll see when it actually happens. Your first three questions are going to be list the reciprocal identities, list the quotient identities, list the Pythagorean identities, and then you're going to do the rest of the quiz. You have to know these in order to be able to do anything we do here on out. Okay? Really, the Pythagorean identities are the ones that you're unfamiliar with at this point. Okay? There are some even odd identities that we're not going to use. If we have time, we'll come back and visit them, but our time is cut by 5 minutes today, and that could be the 5 minutes it would take us to do this, so we're going to skip it and come back. Okay. So, we're going to do a few things. The first thing I want to do is I want to work with doing some factoring. Okay, you guys know how to factor if I have x's and y's, but we need to be able to factor with sines and cosines. Okay, so what I want you to do is write this one down. We're going to factor this.
Is that a 4?
That is a 4. Secant to the 4th x minus 1. How do we factor something like that? Like, what if it was x to the 4th minus 1? How do we factor something like that?
Secant squared x plus 1, secant squared x minus 1.
Okay, very good. This is a difference of squares, isn't it? Okay, so what we can do is we can say, okay, we have secant squared plus 1 and secant squared minus 1. Anything look familiar about either one of those?
Secant squared minus 1.
Okay, so right here, secant squared minus 1 is equal to the tangent of theta. Right? What do we have? We have secant squared minus 1. Oh, and we said what? That's equal to tangent. So what we can do is we can say that this is the tangent of x times secant squared x plus 1. Okay, so we factored it, and then with those factors, we can use an identity and make it look different. So I write this one down. Okay. We have a trinomial, don't we? Right? Okay. We have a trinomial. 4 tangent squared x plus tangent x minus 3. If you need to, off to the side, write it as like 4t squared plus t minus 3 and factor it that way, and then come back to this, that is fine. Okay? So let's go ahead, t for tangent. Sometimes it's just easier with a letter instead of a function. Okay? I want you to factor this trinomial for me. Okay? We all kind of have different ways we like to factor, so I'm going to go ahead and let you do the way that you want. Please factor that trinomial. I promise you it factors. Josie, did you get it to factor? Still working on it? Okay, keep working. Courtney, do you have something? What do you have?
T plus 2 and 2t minus 3.
T plus 2?
Or 2, yeah.
T plus 2 and 4t minus 3?
No, I
2t minus 3. Okay, I think something happened because this multiplies to a negative 6 and we want it to multiply to negative 3. Right? Okay. Josie, did you get it to work? Don't think so? Okay. Well, what do you have? We'll check it in here. And t minus 3. Let's check it. Well, we have the 4t squared and the minus 3, but we have negative 12 plus 1. And we're good. Okay, so maybe let's try switching the 1 and 3. This gives us 4t minus 3t. Does that work? Excellent. So this factors to 4 tangent x minus 3 and tangent x plus 1. The first few problems in your homework assignment will be factoring. There is a reason for that. You won't see it immediately, but next week we're going to work with solving equations, and so getting this factoring practice and now will be helpful. Okay, but factoring will also help when I ask you to simplify a trig expression. Okay, like this. Go ahead and write this one down. Okay. When I ask you to simplify a trig expression, I want you to use a combination of algebra and identities to get this to look different. Okay. So, one thing I noticed, I have 2 terms and both of them have sign. So what could we do with that if we have things that have something in common? Okay, we can factor out a common factor. So if we factor out a sine of x, what do we left here in this term? Cosine squared x minus 1. Okay, now we can look for substitutions. Cosine squared minus 1. Let's go back. We have a trig identity that involves cosine squared and 1, don't we? Okay. we have sine squared plus cosine squared equals 1. Okay? So cosine squared minus 1. If I keep the cosine squared over here and subtract the 1 over, that would mean that we would need to move the sine squared over. Do you agree? Okay. So cosine squared minus 1 is the same as negative sine squared. So this is sine x times negative sine squared x, which is negative sine cubed. Any questions on that one? Okay. It's okay to take an identity. The Pythagorean identities you're not always going to get to use as is. A lot of times you're going to have to adjust them a little bit to make a substitution. Let's look at another example. This one looks very similar to our last one. However, do we have a common factor that we can factor out?
No.
No. Shoot. We're going to have to think of something different. So ideas on what we can do to make this more simple. Simplify. What can we do with cotangent? Can we rewrite cotangent? We sure can. How can we rewrite cotangent? We can write it as 1 over tangent. What else? We can write it as cosine over sine. Okay. So if I write it as cosine over sine, that means that we really have sine of x plus cosine squared x over sine of x. Okay. Now, what happens when I want to try to add two things together and one of them is a fraction? We need a common denominator. What would our common denominator be in this case? Sine of x. So I'm going to multiply this guy by sine of x over sine of x so that we can get a common denominator. Okay. Then I can actually add them together. So we have sine squared x plus cosine squared x over sine of x. What happens to our numerator? What is sine squared plus cosine squared?
1.
It is 1. And 1 over the sine of x? Cosecant. Woohoo.
How were you able to get the cosine and sine squared?
Sine squared plus cosine squared, if you look at your Pythagorean
1,
identities,
okay.
is 1. Next example, write it down. Okay, what are we going to have to do? We have two fractions, which means we're going to have to find a common denominator. So our common denominator, sine of x over sine of x here. This one needs 1 plus cosine x over 1 plus cosine x. Okay? So what we have is sine x over our common denominator. Oh, thank you, sine squared. And this one becomes cosine of x plus cosine squared x over sine of x times 1 plus cosine x. So then we get sine squared plus cosine x plus cosine squared over our common denominator. And what do you notice? Anything in the numerator that you notice? Sine squared plus cosine squared is 1. Ooh, and now what do you notice? And we're left with 1 over sine of x. Ooh, which is? Now, some of you may struggle with knowing when am I simplified, okay? And I will tell you it will get better tomorrow, okay? Whenever we do tomorrow's lesson, it will get better because you'll actually know when you're done. Sometimes you won't really, sometimes there'll be a problem and is this really simple, flat, is simplified, I don't know. Tomorrow it'll get better. There is one more thing I want to go through. It's called trig substitution. Okay? This is important for when you take calculus. Okay? So those of you who have calculus in your future, this is something that you'll eventually use to help you with something that I'm not even going to tell you what it is because you will know what I'm talking about. So if you have calculus friends, they know about integration. That's what this can help us with later on down the road. So they're telling us that x is 2 tangent theta. Okay. So instead of writing 4 plus x squared, we can substitute, this is why it's called trig substitution, 2 tangent theta for x. Now x is being squared. So this becomes 4 tangent squared theta. Okay? So watch this magic. You ready? What number do we have in common down here? We have a 4 in common. So what I can do is I can factor out that 4 and left over we have 1 plus tangent squared theta. 1 plus tangent squared theta. Look at your identities, please. 1 plus tangent squared theta. Layton, what is it? Secant squared theta. So this becomes 4 secant squared theta. And what's the square root of 4 secant squared theta? 2 secant theta. It would not be because we're not solving. If this was an equation and we square root both sides of the equation, then it would be plus or minus. But since we're just making a substitution, no. You want me to raise that up? Now, we have 4 minutes left of class. Realistically, if I give you the homework right now, you're not going to start on it. So I have one more example that we're going to go through. Okay? We're going to go back to our simplifying here. And I'm going to show you a trick when you have something that looks like this. This is not a very long example. Anytime you have in this denominator 1 plus sine of x, okay? We don't really like having a binomial in the denominator, okay? So what we can do is we can multiply it by 1 minus sine of x. What's that called? The conjugate, okay? Why is multiplying by a conjugate helpful? We have these Pythagorean identities. So what this becomes is 1 over sine of x over 1 minus sine squared x. Go back and look at your identities. What is 1 minus sine squared? What is that the same as? Cosine squared. Now, this doesn't really look any simpler. Okay, I feel like we can maybe do something with this. We have the power to split fractions. We have the power to split fractions if we have subtraction or addition in the numerator. What's 1 over cosine squared? Thank you. Okay. And what we can do here with this one, we have 1 sine upstairs and 2 cosines downstairs. So what we can do, we can write this as sine of x over cosine of x times 1 over cosine of x. So we're kind of splitting the multiplication of the denominator. Do you see how that works? Because then what we can do is write this as tangent x secant x. And I'm going to go ahead and stop there. Some of you may struggle with thinking, is this really possible? Okay. My answer, I don't really know. Okay. But I do feel that the problems that I've given you in your homework are a lot easier than the ones that we did here in class. Okay. So here's your homework. Like I said, you're going to do some factoring, and you're going to do some simplifying.
So eventually we'll have to remember all the identities, like we won't need to look.
Right, like on your quiz, the first few questions are